Hi everyone. Today the topic is MST using Kruskals algorithm. We already discussed Prim's algorithm in MST concept. Now the time for Kruskals algorithm. So the algorithm is sort all edges in ascending order. This is the first step. Then select smallest edge. Check cycle. If no cycle is there, then include that edge in the tree. So repeat until V minus edges are selected. So V minus 1 means V is number of vertices. So if vertices is 6 means we need only 5 edges to form the MST using Kruskals algorithm. Okay. So first sort all edges in ascending order. So pick which one is smallest, then check the cycle. Okay, that is very important. If no cycle is there, then only include that edge in the MST. Clear? Okay. So this is the same example I already discussed using the Prim's algorithm. So take the same example. Okay. So now, first step is this. So initially we arrange all the edges in sorted format. So what is the minimum weight here? This 10, right? Then add this edge first, 1 to 6. So next minimum is 12. Then next add 4 to 3. Then next minimum, that is 14. Then 7 to 2. So likewise you sort all the edges one by one. So next, that is 18. Then 22. Then 24. After 14, 16 is there, right? After 16 is minimum, then 18, then 22, then 24, then 25, then 28. So first step is sort all the edges based on the weight. Clear? Based on the weight. Okay. Then select small edges, then add it into the MST. So this is A, B, C, D. These are the step. We add the edges one by one in the MST. So add the vertices one by one in the MST. The step number is denoted as the alphabetical order A, B, C, D because the already vertex name is 1. So to avoid the confusion, I use A, B, C, D for the step number. Okay. So first we add the smallest number, the first edge in the MST. Okay. So add the first edge in the MST, that is 1 to 6. That is the first step. Then we add next smallest edge. So what is the next smallest edge? That is 4 to 3. Okay. Then add this edge in the next. This B is the second step. Then add this edge in the graph. So initially we add 1 to 6 because this is the minimum one. 1 to 6. Okay. Then which one is the minimum weight edge? That is 4 to 3. Then add that is in the graph. MST. 4 to 3 to 4 or 4 to 3. So, okay, this is the step number 2. Then next minimum is 7 to 2. Then add 7 to 2 in MST. So independently connect all those things. Okay, 7 to 2 in the So then connect 7 to 2. Okay. Then which one is minimum? So these all added in the MST, right? So next is 16. 16 is 2 to 3. If add that 2 to 3, we cannot add 2 to 3 in the MST, right? Because we form the cycle here. So if add that thing means we form the cycle, right? 2 to 3. No. So already these are the minimum edges. 1 to 6. 7 to 2, 4 to 3 and next minimum is 2 to 3. Just check the cycle every time. So we connect 2 to 3 here. So here don't form the cycle. So what is the minimum edge? So then next the minimum is 18. So we connect 7 to 4 means we form the cycle here, right? We form the cycle here. So we cannot add the edge in the MST, right? This is the important thing. So we cannot add this thing. So we put it in the cross mark. We cannot add this because it's from the cycle. Clear? Okay. Then what is the possible? Next, we take next smallest one. So next smallest 22, 5 to 4. So we connect 5 to 4. Right? 5 to 4. That is possible. Then next 5 to 7. So we connect 5 to 7 means form cycle, right? So we cannot add this edge in the MST. Clear? Every time you add the edges in the MST, just check the cycle is present. If the cycle is present means don't add that edge in the MST. Clear? The next minimum is 5 to 6. If from 5 to 6, right is possible. So 5 to 6 connect. The next minimum is 1 to 2. So minimum is 1 to 2. This connect to 1 to 2 means this is from one cycle, right? So don't add this edge in the graph. So this is the final MST because we need V minus 1 edges enough to form the MST. So 1, 2, 3, 4, 5, 6 edges are there. So total vertices is 7. Here total vertices is 7. So we only need 6 edges to form the MST. Clear? Edges to form the MST. So this is the step number. Just verify it. What is the difference between Prim's and Kruskals algorithm? Both are from the minimum spanning tree, right? In Prim's algorithm, we start from the minimum edge weight, minimum weighted edges. So 1 to 6, we pick 1 to 6, and then find the minimum weight edges depend on the already added vertices in the MST. That is important concept. So no randomly connect we cannot randomly add all the wedges in the MST, right? So in Prim's algorithm, throughout the connected, we form the MST throughout the previous connected vertices in the MST. So that is the only logic behind this. Otherwise both are same. Okay. In both graph contain no cycle because MST cannot allow the cycle. Then if V vertices are there, V minus 1 edges is enough to form MST. That all things are same because both are MST, right? Prim's and Kruskals. The way of the formation of the graph will differ. Okay, formation of tree will slightly differ in two algorithms, Prim's and Kruskals. Clear? Okay. Here Kruskals we randomly add the edges and finally we form the MST, avoid the cycle. Clear? So total weight is here also 99. The procedure only different. Thank you.